Lesson 4 in Module 4 is on percent increase and decrease. And so we're going to be talking about something's increasing or decreasing. That's easy. But the percent that it's increasing or decreasing compared to the original amount is what we're really working on. It can be a little bit tricky if I don't quite understand the way to do it. So make sure you're paying close attention. So Cassandra likes jewelry. She has 5 rings in her jewelry box. Now, here, I'm sketching these 5 rings. And don't laugh too hard. This is not the major art lesson of lesson 4. So here are my 5 rings. Now it says draw a double number line. So you got to think back to maybe elementary school, relating the number of rings as percents. Okay, so here's what we're going to do. Okay. I'm going to have 2 lines right here. Okay, and we're going to start by the number of rings. There's 5 of them, right? So there's 0, 1, 2, 3, 4, 5, 6. Okay. Fix these a little bit, but squint, okay? So we can see we're doing it right. So again, 0 rings, 1, 2, 3, 4, 5, and 6. Okay, so how do we break that into percents? Well, remember, if we talk about all 5 rings, our total number of rings, right here, that's 100%. So again, remember number lines, we want to break them into equal parts. So if I have 1, 2, 3, 4, 5 sections, I take 100 and divide by 5. Well, we're going to go up by 20. So that's 0%, 20%, 40%, 60%, 80%, and then we have our 100%, which would also mean this is 120%. Okay? So what percent is represented by the whole collection of rings? Well, that's 100%. What percent collection of the rings does, what percent of the collection does each ring represent? Well, each ring, every one represents, sorry, there's 100% representing 5. Every one represents 20%. So this is where we get a little confused sometimes, is that we're going over 100%. That doesn't seem right, but it can be, okay? Because if you have to find that total number, okay, if it's 5 is 100%, okay, and someone gives you another ring, well, you have 120% of what you had before. Okay, and that's what we're going to be working on. So now let's find that percent of increase. Cassandra's aunt said she will buy Cassandra another ring. There's that 6th ring. If Cassandra gets a ring for her birthday, what will be the percent increase in her ring collection? Here's what we know so far. This is what we've learned about percents. Quantity equals percent times whole. Okay. Now, our whole. How many rings does she have? 5. Quantity. How many rings is she increasing by? Because obviously if she gets another one, she's increasing. She's increasing by 1. So now, I won't say that, but in previous lessons, make sure you use this equation. We're going to be doing something a little different. But if you write down the equation, write down what you know, solve for what you don't know, you get P equals, well, 1/5. All right, well, let's talk about that. If I grab a calculator and go 1 divided by 5, I get 0.2. But it's P for percent. I need to find a percent, so I'm going to move it 2 places to the right, the decimal point, and that would be 20%. So this would be a 20% increase, okay, in the number of rings. So, sorry, grabbing my notes here. That leads us to a new type of formula. We could do this every single time the quantity equals percent times whole, but we could do something a little different, which you've seen actually in our power standards. For a percent increase or decrease, you can take the amount of change and divide it by the original amount. So we can take amount of change and divide it by the original amount. Okay, so let's try a couple examples of that. John increased his trading card collection by 5 cards. He originally had 15. What is the percent increase? Okay, so if we could use this to start, I'm going to show you here. We can use quantity equals percent times whole. Let's start with that because we're going to want to show you that way and then our new way. All right, so we don't have a percent because it's asking for a percent increase. We have an original amount, right? Our whole is 15. And he's increasing it by 5. That's the part out of the whole. So we put our P in for percent, and then we solve this equation. We're undoing the multiplication by division. Okay, and I'm going to kind of switch things around here. I get P equals, well, 5 divided by 15 ends up being 0.3333 dot dot dot. Okay? So that's going to be, if we want to make that into a percent, we move it 2 places to the right, and we get it's about 33.3 repeating percent. Okay? But now what if we do our amount of change? What if we do this formula? Amount of change divided by original. So how much are we changing it? 5, right? We're adding 5 on. What's our original amount? 15. Kind of see how we can jump right there. So we get, when you divide that in a calculator, guess what? 0.333 repeating. Move it 2 places to the right, and we still get about 33.3 repeating percent, or you could say 33 1/3%, I guess. Okay. This is just maybe a little bit shorter way of doing it. You can get to the same answer either way. Now, suppose instead of increasing them by 5 cards, he increased by just 1 card. Will the percent increase be the same as when she increased it by 1 ring? Okay, so if we take this again, amount of change. So if he's including, he's increasing 1 card out of the original 15, is that the same as Cassandra, who increased 1 ring out of 5? Okay, do 1/15 and 1/5 equal each other? No. We're going to say no. The part to whole, that's a percent, right? Part out of whole. The part to whole ratio, those are ratios, are different. All right, and that's what we're working on today. Okay, we're working on this lesson, I should say. We're going to be working on finding percent increase or percent decrease. You can use the formula, but I kind of like using our amount of change over original or formula.